Welcome to another GCBASIC set of videos. This is for the PIC18xxQ24 chip family. This is part 1, the basics. This is going to be part 1 of 20 videos, and I'm just using the latest compiler to validate the Q24 chip family works. And alongside of here, there's a set of deep dive videos on how it all worked at the back end. So let the video run all the way through, even if you don't listen to me. Like and subscribe. Those metrics are used by YouTube to promote the video. I don't do the promotion. They get to choose. If you don't like it and you don't subscribe, it doesn't get promoted. So 20 videos. We're going to go from LEDs, ADCs, timers, protocols, communication protocols, PMW, memory, hardware. Lots to cover. GCBASIC is an open source compiler for PICs, AVRs, LGTs, and others, and we're going to prove that the Q24 chip family works. So what we're going to do is we're going to install some software, and we've got a programmer, install a programmer, and just make sure things work. Okay, so where do I get the software from? Well, the best place to get the software from is what's called SourceForge, and I have already been to SourceForge, but I'm going to exit out and I'm going to restart that process. Go into Chrome. I'm using Chrome. Use your favorite search engine. I don't care. Let's not get hung up on that. Let's look at my heating. What's the temperature where I am? This is the weather outside. The weather outside is currently 8 degrees. Heating's off. I'm in the basement. That's my weather machine. Right. This is Bing because I'm using Bing at the moment. They're doing an award program, so I've signed up for that. Enter GCBASIC download in your favorite search engine. If for some reason it's put QBasic behind it, never mind. Download. And it will take you to, will it? That is not my computer. That is Bing. Oh, that's not very good. GCBASIC at the top. Download. Type it in up here. It will take you there. There you go. And it's got many downloads on someone on SourceForge. SourceForge.io, SourceForge.net. Take the SourceForge.net one. That's always a good one because it comes up with this big download button for your operating system. Last updated, you can just work it out 2 days ago. It gets updated continually. And what you're going to do is download GCStudio. GCStudio is a fully managed environment, and I'm going to assume you are capable of installing an application. Take the defaults, just install GCStudio. Take all the defaults. And I'm assuming that you are capable of coming to the right-hand corner when it's finished its download and doing that. And you've had a look, but you can come out and we'll start again. We'll just pretend that you haven't done any of that because our job here in the PowerPoint was to install software. Just install it to its defaults. Now, you need to install a programmer. And I'm going to assume that you can install a programmer, and I've used PIC18 Plus. It's what I use. And if you install PIC18 Plus, it will install it to some default folders, and that's fine as well. And we're going to have a look at some of that in a bit. And then we're going to make sure we got a Q24 attached. Well, look at mine. Look, there's my Q24. It's that thing with that little label on it. Here, look. Q24. I'll change the label for the next video. I've got some LEDs down here attached through some resistors. I've got some switches. I've got some pots. I've got a programmer. I could have chosen a PIC18, PIC18 4. No, that's a 3. PIC18 4. I don't care what you use. I'm using this. My favorite, actually. Why? Because it's got a flying lead on it. It's attached in. Plug it in and put some power on there. There we go. That's the board operational for me. Let's have a look at on the PC to make sure it is actually all working. So inside of my PC, hit the Windows key. I'm just going to type in PIC18, and I'm going to take PIC18 2 plus because it's a 2 programmer, and it will open up my application, and in the application here it shows me quite clearly, I'll bring it into your view, that a PIC18xQ24 is in there, and I can sort of read that, and it's reading it in. I've got it attached. It tells me many things. It tells me that I've got voltage and I've got 3 lines connected. And what we're going to do is just work out the rest of it. Very simple. We have the basics working, and those basics were install the software. We've installed some programming software. You need that because you can't program it. And we tested it. It's attached by using that user interface just now. What I've got is that board. And I'm going to show you that I've got a prototype board. You saw that. I've got some power, I've got a programmer and some LEDs. How they're connected is sort of important because we're going to write some programs very shortly. And I've connected them using this diagram. And you will see a lot of this diagram and it will get developed over time. What I want to draw your attention to are these 4 LEDs here. 1, 2, 3, 4. And they're connected to port B. And they're connected to 0, 1, 2, and 3. How are they connected? Through these little flying leads. Little flying leads come around underneath my board. Got a little leg down here so I can hide those cables. And they're connected at the top here. And they connect through. And I'm going to program one of those LEDs. Well, we might program more if we've got time. Okay. And we're going to make them flash. And we're going to see the camera and we're going to see it happen. I'll come back to VDDIO2 in a later video. It's on the diagram. It's there for a specific reason that we don't forget. So what we're going to do is we're going to open up the set of demonstrations that are specific to this chip. We're going to blink the LED in a couple of ways, and we're going to develop that through 3 programs. So the program place I'm going to use is this location here, and it's in your demo folders, and it should automatically open to there. But if it doesn't, it's GCStudio, GCBASIC demos, vendor boards, Great Cow Basic Demo Board, Q24s. So how do we get to that? Because that's sort of important. Okay. If you've shut down GCStudio, a bit of a loss, press Windows, type in GCStudio, and it should, or you can find it on your own, find GCStudio, and it will open up this window. The first thing it will have done is checked you've got the latest release. Let it complete. If it's doing an update, let it complete. Just keep it up to date. What we've got in here is a list of the files I've been working on. You've got the about, to install the demonstration files if you haven't already done that. You can open a single file, open a folder, create a new project. And we might see some of these as we go through the demos. Donate to the project here, that is important. If you find a bug, click and report it. Let's open a local folder. I've already said where it was. C:\\GCStudio /GCBASIC /demos it was vendor boards, wasn't it? Yeah, VE. I am a vendor for some reason, I don't know why. Vendor boards, Great Cow Basic demonstration board, and then in that long list of demonstration boards, you will find somewhere in there. If you don't want to find it, a quick way to do it is go click like that, and there it is, look, at the top, Q24, because it's the one I'm working on. Select that folder. GC code, which is the code editor, opens up like that. I will go full screen. It might be empty. It might not be empty. It depends. But if it isn't empty, you click on this little file thing at the top, Explorer, or you can press Control B. I don't care which one you do. And in there, you'll find some demonstrations. And there'll be more by the time you get there, because as we develop this, they'll get more and more and more and more and more and more. I want you to take Hello World. You can press Control B. Anything in green in here is a comment. It is the 16th of December, but I wrote this yesterday. And you can sort of minimize it. When you're in here, you can press the little arrow and you can minimize things. To make things bigger, you can press Control plus and Control minus. This is how you specify you're using a 18F26Q24. You type in, if I delete that, I'll just show you. Hash chip 18F, doesn't have to be capitalized, 26Q24, and it's listed. That alone will do the basic setups of the chip for you. It will set up the frequency, the configuration, the basic configuration, and we'll peel back how you change all that later on. Next command, option explicit, always use it. It just means you have to define your variables. We've seen this diagram before, and only if this changes will I actually talk about it from now on. I've got 4 LEDs connected to port B, ports 0, 1, 2, and 3 respectively. And you can minimize that because after that, the hardware is set up, and this is the entirety of the code. We're going to set 1 bit as an output, port B.0 as an output, and then we're going to set it to 1, which is high. To make it program it, you just should check your programmer. If you press function key F4, and there's many ways of doing this, and I'll talk you through lots of different options. Function key F4, type in the word prefs, P-R-E-F, pref. It will take you into the preferences editor, and the preferences editor looks like this. Can I zoom in a bit more for you? I think I can, like that. Essentially, you just want your chosen programmer at the top of this list. There's a vast amount of programmers in here. Just make sure that your one is at the top, and my one is a PIC18 plus command line automatic power on, power off. Why is power on, power off? Because I've got power on my board and I don't want my programmer to keep pushing voltage through. Now, PIC18 plus is a bit special, different from the old versions. It tests for the power being applied anyway, and it won't leave the power turned on from the programmer's point of view, but that's a different debate. Mine is a PIC18 plus, you just need it near the top of the list. Okay. Let's go back to a mode that I call Zen mode. And Zen mode, quite cool, because you can see the program and you can see the camera at the same time. So let me just zoom that down. There we go. There's the camera. And I'm going to press function key F5, or you can select this thing at the top, which is, there's an F for flash, create the, flash the chip, create the azimuth is an A, H is make the hex, and I want hex and flash. So I want hex and flash. Why do I want hex and flash? Because I want to make the hex and flash it. So but function key F5 does the same thing. I pressed function key F5. I went offline for a little cough. It's compiling it. It tells me that it's licensed to me. We'll fancy that. Of course it is. And it's done it. Oh, and if you look in there, we've got a red LED. It works. Let me just shut that window down. Control J. That's the program. Hash chip, specify the chip. Option explicit, we'll come on to that much later. Set that port at bit out and set it to 1. And there's an end. You don't need the end, but I'll just put it there just for completeness. And you can read that on your own. It's not hard. I'm going to shut that program and I'm going to go to full screen mode and we're going to open up another program. Control B, or you can open up the Explorer by tapping on this icon at the top left hand side. You choose. I don't care. Oh, well, actually it says Control Shift E also works. I just use Control B. It's truly quicker. Control B. Now, what we've got is more files in here because we've been compiling things. Control F in here. If you press Control F in that window there, you can type in GCB and it will just apply a filter with a little filter icon. It will just show us the GCP source files. And I want 20, 020 blink. Control B, we're just going to get rid of that. Get rid of the comment field, just hide that for the moment. Hash chip, comma 32. What's that mean? At 32 megahertz. It will always run the chip as fast as it can unless you specify it. And all the calculations on all the timing is all worked out for you. It's like really, really simple. You don't have to worry about the timing. You just go specify the frequency if needed. Typically, most people don't do that. My hardware is the same. This time, I am going to introduce some commands. So dir, the whole of the port will be set to out. All ports in that will be set as outputs. I've got a do loop, which is quite clearly seen, joined together. And I'm going to set all the LEDs, all the ports, all the bits in port B on by setting it to 255. That is equivalent to setting all the bits on. Wait for 500 milliseconds. New command, wait. 500 unit, ms, time units. And you can press function key F1 to get context sensitive help. I pressed F1, it opens up the help for the wait command. I then set all my port to 0, wait 500 milliseconds, and therefore it will flash the LED. Zzz. Function key F5 to program it. I'm going to zip over it into Zen mode, and we're just going to see what's happening. It's just programming it there, look. Is it programming it? Oh, there we go. It works. Now in the background, it's doing other stuff, and we'll go into what's happening in the background later on in other videos. Back to my program here. Full screen. Control B in the GC code and open up Blink another way. And by selecting 030, Control B, it will show us another way to blink things. Same header. I'm now defining my ports as constants. Constants are cool because if you use a constant, you just have to change one thing, the constant, and it all works. So I've defined 4 constants for my 4 LEDs, and after that, I'm just going to refer to the LEDs as LED and the constant. So I've defined 4 constants. I set the 4 constants as out, and then down here, I can then select which LED I want to flash. I don't have to go port B or anything. I can just refer to the constant, which is a lot faster. And what we'll do is we'll change this constant here and we'll see what happens in our program. So I'm going to leave that there, press function key F5, go to Zen mode. It opens up the programming dialog, and it was still flashing from the last time quite clearly, but now it's going to flash to 1 LED. And if I wanted to change that, I would just change my constant. But we've introduced an awful lot of concepts. We've installed the software, made sure the board works, and got some LEDs flashing. That gives you confidence around the tool chain. LEDs now flashing. We'll move on to rotating the LEDs and using other techniques in later videos. But we need to get the basics operational, and that is the basics, which is, these are complete programs. Yeah, it's generating assembly files, hexadecimal files. It's transferring it from your workstation into the programmer, into the chip. All that magic is happening in the background. Not important, because it's the outcome we're looking for here, which is an LED flashing. If you got confidence from GCBASIC that the LED flashed, you might find confidence to go and learn a C-based language. Nothing wrong with that at all. It's a great step. But if it works in GCBASIC, it will definitely work in C. It's just that you can generate code a lot faster in GCBASIC. but it will give you the confidence to move forward. Next time, we're going to make the 4 LEDs flash in sequence. It'd be exciting. Enjoy.